Assalamualaikum warahmatullahi wabarakatuh. So today our group, which is group 3 for industrialized building system subject, will present about our case study where the title is Small Most Industrialized Building System (IBS) at Pagoh Education Hub Facility. So our members in group 3 is Azwan, Salim. Second, Fazli, Muhamad, Diah. Third is Fariz, Abdul, Wahab. Fourth is Nurhakimi bin Roslan. And last, as for the introduction, the industrialized building system in Malaysia began in the 1960s, where Ministry of Housing and Local Government visited many European municipalities to study their housing plans. Following a successful visit in 1964, the Malaysian government initiated a project to evaluate the effectiveness of IBS. So the Malaysian government has been significant efforts to promote to use the IBS as an alternative building technology. So there are many definitions of IBS. Such as off-site production, industrialized and automated construction, off-site manufacturing, prefabricated buildings, and so on. So an industrialized building system, according to the Construction Industry Development Board, which is CIDB, it is a construction system in which its components are created in a form on or off-site and then inserted and integrated into the structure with minimal additional site labor. So according to CIDB, there are 5 forms of IBS, where the first is precast concrete frame system, where this precast concrete include the structures such as columns, beams, slabs, 3D components, and so on. So second is steel formwork system with tunnel, where can see it in the figure. And the third is steel frame system, where it consists of steel beams and columns. And fourth is prefabricated wood frame system, or can be said prefabricated timber frame system. Also can see it in the figure. And the last one is blockwork system, this includes interlocking concrete masonry units and so on. So as for this project, there are 2 objectives where the goals of this study is identifying the breakdown and connection system of a building in Pagoh, as well as number 2 is determining the facility's IBS score. So the target of our study is a small mosque within the Pagoh Education Hub facilities, which is near the library and bordered by numerous institutions including UTHM, University Tun Hussein of Malaysia, our university, and also University Technology Malaysia, UTM.
Okay, now I will explain about type of connection system. Okay. There are 3 types of connection system that have been related to our design. Okay, the first one is the column base plate connection. In basic construction, a simple rectangular or square base plate is usually utilized for columns. The base plate should be large enough and strong enough to transmit axial compressive force from the column to the foundation through the bedding material without exceeding the foundation's local bearing resistance. This type of connection can be implemented at the column as shown in figure 1.1. Okay, the second connection system is flexible end plate connection. Okay, figure 2.1 depicts the typical flexible end plate connections that can be implemented. In the workshop, the end plate, which might be partial or full depth, is welded to the supporting beam. On site, the beam is attached to the supporting beam or column. This sort of connection is reasonably affordable, but it has the disadvantage of limiting site adjustability options. Although pegs can be utilized to compensate for fabrication and erection imperfections, overall beam lengths must be produced within certain restriction.
Now I'll be explaining about the fin plate connection. So as you can see on the right side is the figure that shows the design and the arrow pointing to the wall. This is where the connection will be implemented. So the fin plate connections are inexpensive to make and simple to install. These connections are popular because they are easy to install and eliminate the problem of shed bolts in two-sided connections. As indicated in figure 3.1, a fin plate connection consists of a line of plate welded in the workshop. The supporting element can be implemented to which the supported beam is attached on site. Between the end of the supported beam and the supporting column, there is a little gap. So now I'm going to explain about the overall Arabic 3D design of small mosque. And as you can see here, this is the design that we have made. So now I'll be explaining about the filler table. As you can see here, the filler table consists of facts, ideas, learning issues, and selection plan. So for the first fact is the difficulties of erection and transportation to the site. The ideas for this fact is value for each component of IBS concrete should not exceed 7 tons. Next one, precast concrete in partial sizes where can be plugged and play to become large scale precast concrete. And next is the learning issues, while the components should not exceed 7 tons. And the second one is, does the traditional precast concrete do not efficient? And for the second fact is the limitation radius of transporting IBS component is 50 km. The idea about this is the suitable distance from the new potential development area to the fabrication plant should be the distance varies from 50 km to 100 km. The learning issues is what is the effect of the distance which more than 50 km to 100 km radius. And the third fact is the high initial cost. The idea is require a specific type of equipment and machinery to produce the required component. The learning issue is the specific machinery and equipment are needed to produce the different IBS components. The fourth fact is the designing a feasible IBS system. The idea of this fact is to provide a feasible and innovative IBS system that is acceptable to those involved with construction as well as the users. As for the learning issue is how to achieve a feasible IBS system. And the last fact is problem faced in connection used between two structures. The idea of this fact is identify sizes and dimensions of the structures to be connected. As for the learning issue, how to select the type of connection to be used. So for the action plan, all of this fact is taken from article and journal research.
Assalamualaikum, my name is Fazli and I will continue our presentation on IBS scoring system. IBS scoring system is put its emphasis on following attributes such as usage of IBS component, utilization of standard components based on MS1064, 3 repetition of structural layout, and usage of other productivity enhancing solutions such as volumetric modular units, information modeling (BIM), and modular grid lines. The scoring system is divided into 3 parts, which is part 1 is structural system, part 2 wall system, and part 3 is other simplified construction. Structural system is point awarded to the variety of structural technologies that used in construction, including column, slab, precast concrete, load bearing block, in situ concrete using reusable formwork, and various combination. And second system is wall system, which is its emphasis on the type of wall system that used in the construction, such as precast concrete panel walls, or dry wall system, or maybe blockwork system and others, and it can determine how many points are granted. both structural system and wall system use a formula to calculate the scoring, as you can see in the slide. And the third part is other simplified construction, emphasis on the utilization of modular units, drawing grid lines and BIM, and each given requirement is capped at 30 points.
Azwan Salim. So today I'm gonna talk about the result and calculation. So I'm gonna explain it as simple as I can. So as we can see here, there are there are 3 parts in the table of IBS score. The first one is structure, second part is wall system, and the third part is other simplified construction solution. So we go to the part 1. The part 1, we can see here they have a pre-concrete column, beam plus in situ concrete slab using timber formwork for the floor plan. The area is 302 meter square, and we can see the IBS score is 22.5. Next one is roof truss using prefab timber. The area also same, 302 meter square, and the IBS score is 25. So the total part for the IBS score is 47.5. 47.5 over 50, because the part 1, the full mark is 50. Okay, we go to the second part. The second part is wall system. As we all know, they have two type. The first one is external wall, and second one is internal wall. So for the area of external wall, they have 70.10 meter, and the IBS score is 6.9. The internal wall, the area is 31.95 meter, half from the external, and the score is 6.2. So for the total part for part 2 is 13.1 over 20. And last part is other simplified construction solution. I'm just gonna tell the IBS score. The first one is beam size, about 80% coverage used for the IBS. We got the mark. The mark we got here is full mark 4. The second one is 100% column. The score we got is also for full mark. Second one is the third one is 60% of wall. We got half mark, which is 2. Also for the slab, the score was same. We got 2, and the door we got 100% IBS, which is 4 full mark. And lastly, horizontal repetition for structure, also 100%. We got 6. So the total for part 3 is total mark for part 3 is 22 over 30. So the IBS score for the wall part is 82.6 over 100. So other than that is the internal wall we use precast concrete, and the external we use precast masonry block. I think for the total construction, They have 604 meters square. I think that's all for me. Thank you.
The next is discussion for our calculation just now. The overall score for this building after using the scoring system is 80.6 points. As a result, the building IBS score made the government and non-government project IBS score criteria of 70% for all projects. So based on the calculation, the score for each part is 47.5 for part 1, 13.1 for part 2 and 20 for part 3. However, the three components, particularly part 2, which obtained the lowest score of 13.1, can be improved because of the length of a certain wall system used as a percentage of the total wall length of project is low. So that's why part 2 obtained the low score. The number of points awarded is determined on the type of wall system that used in this construction, such as precast concrete panels. Okay, so as a result, part 2 IBS score was so low. So the idea for this structure will be enlarge the construction area as well as the wall length in order to obtain a higher score for part 2. So finally, a better IBS score can help to increase the project quality, and a higher score suggests fewer site labor, waste and materials, as well as a cleaner environment and reduced building costs.
So, as for the conclusion, the study on the small malls IBS industrialized building system at Pago Education Hub facility objectives is identifying the breakdown and connection system of a building in Pago, as well as determining the facilities IBS score by using Revit software as technology for drawing the small malls and calculate IBS score at the end. So for objective 1, which is to identify the breakdown and connection system of a building in Pago, from the drawing where we are using Revit software, there are a few breakdown systems where need to be improved and connection system to be found in the studies, such as column-based plate connection, flexible end plate connection, and fin plate connection. Hence, the objective of 1 has been fulfilled. Second, for objective 2, the objective is determine the facilities IBS score. Based on the result being calculated for 3 parts, the overall IBS score for small malls is 80.6. This showing that this building is using IBS and follow the standard criteria stated by the government, where the minimum point for IBS score is in a building is 70%. By implementing IBS in a building, the safety of the public can be guaranteed, and the building is made for long-term use. Hence, objective 2 has been fulfilled.